So today we're going to talk about Bernoulli's principle, and whether or not you realize it, you come in contact with Bernoulli's principle every day, especially when you happen to be in an airplane. So we're going to learn a little bit about the physics behind how airplanes fly, specifically as relates to a very fundamental principle called Bernoulli's principle. To complete these notes and video, there is a notes page listed on the lesson website. Feel free to download that now if you need to. And we will start at the very beginning. So slide 1 talks about what is Bernoulli's principle, and you're going to fill in the blanks as we go. So if you need to pause this video as we proceed, making sure that you have the time to fill in the words that need to be filled in on your sheet, feel free to do so. But in a nutshell, what we're going to really discover is Bernoulli's principle. And the definition, it's rather dry, but really it's that the pressure exerted by a moving fluid, so a fluid can be either a liquid or a gas, the pressure of that moving fluid is less than the pressure of the fluid that surrounds it. And basically what that means is that when a fluid is moving faster relative to a fluid near it, it has less pressure. And reverse of that, slower fluids have greater pressure. They exert a greater pressure on an object. And the difference in that pressure causes the slower moving fluid to move into the space of the faster moving fluid. But what does this mean? So there have been various examples that we've talked about in class during our labs, and let's talk through what some of those examples are now. So the first thing I'm going to suggest is if you can get a piece of paper and just place it under your chin, kind of rest it on the bottom of your lower lip, and hold the edges next to it, and then gently blow across the top of that paper. Go ahead and pause this for a second and see what happens. I'll give you a minute. So hopefully you've had a chance to experiment with this on your own. I'm going to give you the answer basically. Hopefully you were able to find this out for yourself. But when you blow across the top of that paper, something happens to the paper. Maybe you expected it to go down, but in actuality it goes up. And that's because you're creating less pressure on the top of that paper because you're blowing across it quickly. The slower air is underneath it, and that causes a greater pressure, and it makes that paper move up. So when you do this, when you blow across the top of the paper, you're creating fast air, which means it has less pressure. Underneath is slow air, and slow air has greater pressure. That greater pressure is going to push that paper up. Example 2. So if you've ever been in a shower when there's been a shower curtain, I like to call this the attack of the shower curtain. So you're minding your own business, trying to get clean or whatever, and all of a sudden you turn the water on and the shower curtain attacks you. Basically, think about what's happening. You're introducing a faster moving fluid inside the tub area, and that fluid, because it is moving faster than the fluid on the other side of the shower curtain, it has less pressure than the air on the other side of the curtain. That air is moving slower, so it has more pressure. And introducing that difference in pressure on either side of the curtain causes the shower curtain to be pushed in toward you. And that's when you feel like you're being attacked by your shower curtain. Example number 3. So we did this on the lab on that Friday when we experimented with a little index card tent, and then we attempted to blow underneath that tent to see what would happen. And what we discovered was the slower air, because it's on top of the index card, has more pressure. So it's going to exert more pressure on top of that index card. The faster moving fluid is underneath, and it has less pressure. So the more pressure is going to create that greater force on top of the index card, and it's going to cause that card to be pushed down. Okay? Let's go to number 4. So if you've been in a windstorm, hurricane, I've been in a lot of these, you can kind of see the windows kind of being pushed out a little bit when you're in the height of the storm. And that's because with these storms, there's a huge difference in air pressure. That's what causes these storms, these low pressure areas. And you can feel sometimes a greater pressure happening inside your home or inside your apartment than you experience outside. You can actually see the windows bulging, and it's really unnerving. And it's really because we've got low pressure on the outside of the house because that wind is blowing so fast, right? So that fast moving air has much lower pressure than the pressure that's inside the house. And it can be such a strong differential in pressure, especially in tornadoes or in very severe hurricanes, that sometimes those roofs can pop right off. And you see that sometimes in the footage of after storms happen. The roof can actually be popped right off as a result of these incredible storms. So next time you're in a hurricane, watch your windows. And in fact, you might just want to open up your windows ever so slightly so that you can equalize the pressure on either side of your walls, make it a safer environment for everybody at home. All right, example number 5. This can be a little scary. This has actually happened to me several times. You're on a highway and you're moving along when you're in a little car and a truck comes up right next to you really, really fast. And what happens is that you're moving slower, so the air around you is slower and has greater pressure, and yet the air on the other side is moving much faster because that's what that truck is creating, is faster air. And the result is, and it can be kind of scary, is your car getting pushed towards the truck. It's a little unnerving, and if you're a driver, once you learn how to drive a car, you'll experience this. You'll just have to kind of put a little extra pressure on the steering wheel, put a little stronger grip so you don't drift over, because that can be a little scary. So you can try this at home. Example number 6, spoon and faucet. So you can just take a second, go get a spoon and turn on the faucet in your sink and just let the spoon dangle next to it and see what happens. You will see that the faster moving fluid, much like the shower, has less pressure than the air surrounding it and the spoon, and the result is that your spoon can be pushed towards the water. It's a little weird to watch because you're not doing anything to it except just observing that the spoon's moving towards the water. So what does this all mean in terms of flight? Well, if you look at the shape of an airplane, you can see that the air that hits the wing and is pushed above the wing has to move faster in order to catch up with the air underneath it. It has a farther distance to travel. So because that air has a farther distance to travel, it has to move much faster. And then, as we've learned, when that air is moving faster, it has less pressure than the air underneath it. And the result is you've got a pressure differential where underneath the wing, the air is greater pressure and it's pushing that wing up. And that is what causes lift on an airplane. It also causes drag because of the angle in which the airplane wing is getting hit by the wind. There's a little bit of drag that's happening, and that's essential too as an opposing force for thrust. So there you go. There's Bernoulli's principle in flight, and I hope you enjoyed this little video. Bring this to class with you when we reconvene. Thank you.